Okay, hi. So we're going to talk about translations of sine and cosine graphs. So I want to talk about a little bit of vocabulary, and then I want to build up some intuition with this. So, okay, first of all, so horizontal translations in general. You've seen this in other classes, and we describe this as having something inside of the graph. So this is the way that we mathematically state this, f of x minus d. And the way that a graph will shift actually moves in the opposite direction of what you think. So if I have minus d, then I'm going to move d units to the right. And if it says plus d, it's going to be d units to the left. So this is just a reminder. If you have no idea what I'm talking about and you're like, this makes no sense, don't worry. I'm going to show you an example in a second. So just hold tight. So I want to just introduce some vocabulary that is specific to trig. So the word phase shift, this is what we call horizontal translations when we're talking about trig functions, okay? Circular functions or trig functions. So phase shift is what we use instead of horizontal translations. Sometimes I refer back and forth between these two just so that you kind of remember like what it's supposed to represent. And we have an argument. So if you have f of x minus d, the x minus d is what we call the argument. So sometimes I will refer to that as well. And the other thing I want to talk about is what is a vertical translation. So a vertical translation looks like this. You can have c plus a function. So I want you to notice the difference between this, right? So you have either you're adding or subtracting a number kind of inside of the function, or you're adding or subtracting a number outside of the function. That's the big thing with translations is where are you adding that number? So if you have this c, this will move a graph either c units up or minus c means c units down. So I just want to build up the intuition with you in case you have forgotten how this works. So we're going to take a quick field trip to desmos.com just to familiarize ourselves with this. So I'm going to formalize how all of this works in this video. This is kind of a longer video, but I just want to help you develop a little bit of intuition. So I want you to notice, so I've got sine of x, that's my base graph. And I just want to notice what happens to the graph when I add numbers to that function. So I always think of, so phase shift or horizontal shift, that requires a number on the inside of the function. That's what I mean. This is what I mean. Sine of x plus 3, x minus 2. These are, I always think of this as an action happening inside of the function. Versus if you look at these two, 1 plus sine of x, negative 4 plus sine of x, you see how this is nowhere near, this is not inside, right? This is clearly outside of the function. That's an important distinction to make, and we'll talk more about that. So what happens if I am adding a number inside the function? So pay attention to what's happening to the black line. So if I add 3, this thing just really shifted to the, well, officially it shifted 3 to the left. And then I have sine of x minus 2. So notice that once again, the red line now has just shifted again. Technically, this has shifted 2 to the right. This is called a phase shift. It's hard to tell if it's shifted to the left or to the right, so I wouldn't get too hung up on that, and we'll formalize that more a little bit later on. But the big thing to know is with a number being inside of the function, it's going to horizontally shift the function left or right, okay? So what about if I have a number outside of the function? So if I have like 1 plus sine of x, what does that do? That literally pushes the function up 1. Versus if I have something like negative 4 plus sine of x, look at what happens. Now that pushes the function down 4. So that is what's known as a vertical shift or a vertical translation. And so it's literally the same graph, just moved up or down. And you can, of course, combine these. So if I have like negative 3 plus sine of x plus 1, so just notice what happens. This still looks like the graph of sine, right? But now it has been shifted horizontally and down. So we will unpack that in this video. And you can also mess with the period too. So in this case now I've messed with my period, and I've still got, I've also shifted to the left and to the right. So there's just a lot to unpack here. So let's get into it. So like I was kind of alluding to, and I want to just address this now so that you can think about this as we move forward in the video. So determining the phase shift can be tricky if you have a function that's like of this form, a cosine bx minus c. And this could work for sine or cosine. I just randomly selected cosine. So what gets tricky about figuring out the phase shift, like how much a graph is actually shifting one way or the other, is if you have a number here attached to the x. This kind of makes everything tricky. So I want to address this right away so that you can like notice this kind of going forward. So if I have a function a cosine bx minus c, so to calculate the phase shift, what I'm always going to do is I'm going to take c over b. So I want you to notice that that is the opposite sign of c. So that's something that you've got to get used to. That's kind of works with all horizontal translations. You usually take the opposite sign. So that's just, you can really just think of it as that's how that works. So just to complete this thought, so if you had something like a cosine bx plus c, so I'd have to take the opposite sign of c, right? So the phase shift in this case would be negative c over b. So I'm going to show you how to use all of this as we move forward. So I think the first thing that we want to do here is we want to get used to looking at these functions and knowing what is happening to them. So in this case, I've got y equals sine of x plus pi over 2, and I want to find amplitude, period, phase shift, and vertical translations. So looking at this, this is just the graph of sine x, but it's just been translated, this pi over 2. So how do we interpret that? Okay, so first of all, the amplitude is whatever number is in front of your trig function. There's an invisible 1 here, so my amplitude, of course, is going to be 1. My period, so to figure out the period, you take whatever number is in front of the x. There's an invisible 1 here, right? So you take 2 pi divided by that number, so 2 pi divided by 1 is just 2 pi, so the period is 2 pi. So now for the phase shift. So what you're looking for when you are discussing phase shift, you take the opposite sign in front here, so notice I wrote negative pi over 2, and divide that by whatever number is in front of the x. So in this case, there's no number in front of the x. We interpret that as an invisible 1. So my phase shift in this case is going to be negative pi over 2 divided by 1. So that just comes out to be negative pi over 2. So what we would say then is that this graph shifts negative pi over 2 units. So you could think of that then it's moving pi over 2 units to the left. So it's a horizontal translation, but again, we like slightly tweak how we think about this for trig functions. And then the last thing is the vertical translation. So there's no number on the outside of this function. Everything's happening on the inside of this function. You could think of this as there's like an invisible plus 0. This graph has no vertical translation. Its vertical translation is 0, okay? All right, so we're going to do this a bunch of times to really get you used to looking at this, because this is like a code that will really help you with graphing. So I want to practice this a bunch because then it really empowers you to work through this. So now I've got y equals 2 minus sine x. Okay, so let's do the same thing. Amplitude, there's no number in front of sine, right? So, well, I guess you could say there's a negative 1 technically in front of it. Amplitude is always just the absolute value of whatever number is in front of your trig function. So there's an invisible 1 or negative 1 here. Amplitude is 1, okay? Next, period. So there is no number attached to the x. So I'll just take 2 pi divided by 1. That's the invisible 1 here. So the period is 2 pi. My phase shift in this case. So all I have here is sine of x. If you have just x by itself and there's no plus or minus number to that, then the phase shift will just be 0. So no phase shift in this case. And then the vertical translation, so notice in this case, right, there's a number outside of the trig function, so the vertical translation is going to be 2. Okay, so now I want you to try. So we've got this is a problem now that has both a vertical translation and a phase shift. So using the notes from the last 2 examples, I want you to pause here and take a moment just to put everything together and see if this is making sense to you, and then hit play when you're ready. Okay, so in this case, so amplitude and period, I feel like we should know that. So my amplitude, there's no number in front of the sine, amplitude's 1. And then for the period, there's no number attached to the x, so the period is 2 pi. So okay, we're all good on that. And then phase shift. So for the phase shift, so remember I take the opposite sign. So this is positive 2, so it's going to be negative 2 divided by whatever number is in front of the x. There's no number in front of the x, so phase shift is negative 2 divided by 1. So phase shift is just going to be negative 2. And then finally, we have vertical translation. So that's the number on the outside. That's 3. So this graph moves 3 up and 2 left. Okay, so let's try that one more time. You try this one once again on your own. If you made a mistake in the last one, no worries. You're just trying to get better at this. You'll never get better at this if you don't practice. So even if you make a mistake, it's okay. Pause here, hit play when you're ready. Okay, so my amplitude, now I have a number right in front of my trig function, so that's 1/2, so amplitude's 1/2. Period is still 2 pi, there's no number in front of the x. The phase shift, so the phase shift is 0 because it's just x, right? It's not x plus a number. So if it's just x, your phase shift is automatically 0. And the vertical translation is this number right here, boop, -4. Okay, so let's make things a little more difficult now with figuring out the phase shift, just to get used to that. So I've got y equals 2 plus sine of 2x minus 2 pi. So let's go through this together. Okay, amplitude is 1, right? Because there's no number in front of the sine. For the period, now I've got a 2 attached to my x. So I'm going to take 2 pi divided by this 2. So my period is pi. And then my phase shift, so now I take the opposite of this. So this says -2 pi. So I take 2 pi divided by this number here. So 2 pi divided by 2 is going to equal pi. That's my phase shift. So technically this graph is moving pi units to the right. And the vertical translation in this case will be 2. That's the number on the outside. Okay, let's do that again. So another one together. So I've got 1 minus 2 cosine 3x plus pi over 2. So same thing. So first amplitude and period. So amplitude is going to be 2, right? Because that's the number in front of the trig function. And then the period is 2 pi divided by 3. That 3 comes from right here. Okay, so that part we should feel pretty good with. So now for the phase shift. The phase shift, remember, I'm going to take the opposite of this divided by this. So that's going to be -pi over 2 divided by 3. So now I just have to sort out the math with this. So that's going to be -pi over 2 divided by 3, which is the same thing as -pi over 2 times 1 over 3. So my phase shift in this case is -pi over 6. And then what's my vertical translation? That's the number on the outside just hanging out over here. So my vertical translation will be equal to 1. Okay, so hopefully now you're kind of putting some of this together. So now I want you to pause the video here, and I want you to try to find those 4 pieces of information on your own and hit play when you're ready. Remember, math is not a spectator sport. Okay, amplitude is 4, period is 2 pi over 3, right? There's 3 here. So the phase shift, so I take the opposite sign. This is +1, so I'm going to write -1 divided by 3. Phase shift is -1 over 3. And the vertical translation is 2. Boop, this number right here. All right, so next, let's try one more. Let's make sure that you've got it. Pause here. You give it a try. Hit play when you're ready. Okay, amplitude and period. Amplitude is 2. Period is 2 pi divided by this pi right here. So my period is 2. And then my phase shift will be 3 over pi. So once again, I take the opposite of this. This is -3, so this becomes +3 over pi. So 3 over pi, and the vertical translation is this number here, 3 pi. Okay, so that's kind of like one of the first things you want to be able to do when you're graphing these translations. So I know we did a bunch of examples on that, but that's like really key to kind of getting through this. Now, when we have a period other than 2 pi and a horizontal translation, the starting point is not going to be 0. So when we are initially talking about how to graph sine and cosine, we didn't have any horizontal translations. So we need to just do a little bit of work to figure out, like, where should I start my graph? Now, technically, you could start graphing wherever you want, but I think it's good to have a unified system in place because it makes it like more straightforward in how to graph these. So I want to show you a system of how to actually graph all of this. Okay, so all I want to do is I want to show you, like, where should you start graphing and end graphing? How do you figure that out when you have different translations? So I'm going to use, once again, sine of x plus pi over 2. So what we're going to do is we're going to solve a 3-part inequality. So the inequality will always be the same. You take the argument, you take the stuff in here, just the stuff in here, and you wedge it between 0 and 2 pi. And that should make sense. That's kind of like where we start and end for the regular graphs of sine and cosine, right? So we take what's inside here and then we just see how should we adjust our starting and ending point based on like this new scenario, okay? So to solve this three-part inequality, all I need to do is I need to think about how would I get x by itself. So to do that, I would subtract pi over 2, and I just subtract pi over 2 from all sides like you see here. So boom, boom, boom. And then I just do the math. So this becomes negative pi over 2 is less than or equal to x, which is less than or equal to 3 pi over 2. And so the interpretation of this then is that this is going to be the start where we graph, and this will be the end. So this is very, very powerful to get you a framework for graphing and to make things much more straightforward. Okay, so let's look at another example. We've got y equals 1 minus 2 cosine 3x plus pi over 2. Okay, so again, all I care about now is just the starting and ending point, so this little exercise. So I'm going to take this inside part, and I'm going to wedge it between 0 and 2 pi, and then I'm just going to go through the work to solve for x. Now, I would recommend, just to check that you understand this, I would recommend that you pause here and you try to work this out on your own and then hit play when you're ready, and I'll show you the steps to do that. And if you made a mistake, then you'll just learn from it, and then it'll be fine and we'll move on. So pause here, hit play when you're ready. Okay, so to solve for x, the first thing that I want to do, I want to subtract pi over 2 from all sides like you see here. And so now I have this inequality, and I'm not done solving for x, right? This is 3x. So then the other thing that I need to do then is I need to divide all sides by 3. Now in dividing all sides by 3, that might be a little bit confusing. You might want to actually like write out the division in this case. So what I mean by that is like, so negative pi over 2 divided by 3. So see how I've written that out, negative pi over 2 divided by 3. That becomes negative pi over 2 times 1 over 3. So this will equal negative pi over 6. And then I can do the same thing for 3 pi over 2 divided by 3. So I've got my math here, and that will ultimately work out to pi over 2. So you can just, if you need to pause, you can double check the math if you had any trouble with that. Okay, so what does this allow me to do now? This allows me to know where I want to start my graph and where I want to end my graph. So we're coming up with like a pretty good framework. All right, so now I want you to try this totally on your own. Find that starting and ending point, and then hit play when you think you've got it. Okay, so I'm going to take just the inside part, right, and wedge it between 0 and 2 pi, and then I'll go through and I'll solve for x. So I add 3 to all sides, and then I'm going to be left with this inequality here. Now, I know that this probably felt a little bit awkward because I've got 2 pi plus 3. Just leave this as 2 pi plus 3. Don't worry about it, okay? So let's keep going. So if I divide all sides by pi, so look at what happens now. I could break 2 pi plus 3 over pi. I can break this into two parts. 2 pi over pi plus 3 pi over, 2 pi over pi plus 3 over pi. So this will simplify then to the pi's will cancel out, right? So I'm left with 2 plus 3 over pi, and then this side will be 3 over pi. So once again, now I've got my start and my end. Okay, so we have really all the pieces now to get through this process. So I want to just talk about the steps you should always use for graphing sine and cosine. So of course you always want to identify the period and the amplitude. This actually will be very important when you have translations and working between your starting and ending points. You always want to find that start and end point. So using that three-part inequality and then solving for x. So that's what we were doing in that last set of exercises. And then the next thing that you want to do, and this is what I'm going to show you how to do in the next few exercises, is you create a table of points, and you want to find 5 points to graph the function, and you take steps between each points by taking the period and dividing it by 4. So I'm going to show you how all of that works now. Okay, so let's use the example y equals sine of x plus pi over 4. So, okay, technically, so if we think about the phase shift, so what is the phase shift in this case, just looking at this function? The phase shift in this case is going to be negative pi over 4. So I just want to go back to like horizontal translations. So technically, what way does this graph move? I just want to like bring this all back together. Technically, this graph is moving pi over 4 units to the left. And so what do we want to do next? We want to solve this 3-part inequality. So if I solve this 3-part inequality by subtracting pi over 4 from all sides, this is what I'm left with. And so what I want to start with is, so I just want to like connect this all for you and make a little bit more sense of this so you have greater intuition. So this graph technically moved pi over 4 units left. So notice that instead of starting at 0, the whole graph shifted pi over 4 units left and starts at negative pi over 4. So if that doesn't make sense, don't worry about it. You could just use the steps, but just trying to help you build a little bit of intuition so that you're not just feeling around in the dark doing a bunch of random steps that don't make sense. So the starting point has to do with how far this graph moved to the left. Okay, so we know the starting point is negative pi over 4. And then if I want to identify my period and my amplitude, so my period is just going to be 2 pi, right? Because there's nothing in front of the x. And then the amplitude is just 1. Okay, so since this graph was shifted left to pi over 4, so we're going to walk through the example sine of x plus pi over 4. Okay, so like I said, the first thing that you really want to do is identify your amplitude and period. And I think it's good to note if you have a phase shift or a vertical translation. So even though that's not like something I put in the steps, like it's a good thing just to note because it will give you some intuition as to what should happen with the graph. So there's no number on the outside, so there's no vertical translation in this case. But the amplitude is going to be 1, right? There's no number in front of this, so we just assume it's 1. The period is 2 pi over 1. There's no number attached to the x, so the period is just going to be 2 pi. And then the phase shift is just going to be the opposite sign here, negative pi over 4. And since this is all divided by 1, the phase shift is negative pi over 4. So this is really just the graph of sine, the normal old graph of sine, shifted pi over 4 units to the left, okay? So that just gives us some intuition as to what should be happening with the graph. So next I want to figure out my starting and ending points. So I take this inside piece, right, and I wedge it into this inequality. So I can go ahead and solve by subtracting pi over 4 from all sides. So I get negative pi over 4 is less than or equal to x, which is less than or equal to 7 pi over 4. So I've got my starting point and my ending point. So this is what I'm going to fill into my table in a moment. You'll see how I interpret this information. Now, the last thing that we haven't done together that I'm going to show you how to do now in these next examples is you want to know how big of steps to take. To figure that out, what you're going to do is you're going to take the period and you're going to divide it by 4. So I'm going to start here, and then on my table, I'm going to take pi over 2 sized steps. Okay, so I start at negative pi over 4, right? That was what I said my starting point was. And then I want to start to take pi over 2 steps. So what does that look like? I take negative pi over 4 plus pi over 2. If I do this math, I get pi over 4. That's going to be the next step in my table. So that's how you interpret that. So then what I'm going to do is I'm going to keep adding pi over 2 steps. Now, when you're figuring out the math on this, you might want to rewrite, instead of having this as pi over 2, you might want to think about this so that you have a common denominator just to make the math easier, right? Pi over 2 is equal to 2 pi over 4. So I'm going to add 2 pi over 4 to each step here. So if I take pi over 4 plus 2 pi over 4, the next step on this table will be 3 pi over 4, right? Pi over 4 plus 2 pi over 4 is 3 pi over 4. And now if I continue that, the next step will be 5 pi over 4. That's because I take the previous step, 3 pi over 4, and once again I add that step of 2 pi over 4. So we're just adding these pi over 2 steps to each rung here on this table. So now I've got 5 pi over 4. And then I can continue this, right? So if I continue the pattern, I get 7 pi over 4. So this is 1, 2, 3, 4, 5 steps. So we're good to go here. And just to kind of keep going with the pattern, the next step, if I wanted to keep going, would be 9 pi over 4. I think that it can be nice to do an extra step just to double check your math. This is like a very easy way to program in just an extra check for yourself. So I'll show you how this works and you can decide if you want to use this option. It's like a good option to use for tests and stuff. Again, just to make sure you're doing your math right. Okay. So now that I've done all that, now we need to find the y's. And so what you're going to find is in how we construct this table, this is actually going to end up being a very clever way to construct the table because it's actually going to make the math for evaluation much easier. So let's go through and do this. So I'll get rid of the graph for a moment and let's just plug some stuff in. So for instance, if I've got negative pi over 4, so if I plug that in, so notice what happens. I got sine of negative pi over 4 plus pi over 4. That just comes out to sine of 0, which is really easy to evaluate. So all of this work that we're doing, actually, I'm going to just like spoil the punchline for you here. All of the work that we're doing here is to ultimately make the calculations something familiar and easy. That's why we put in all this work so that ultimately it's much easier to evaluate this. So sine of 0, of course, is just 0. So if I continue on, so what about sine of pi over 4? Sine of pi over 4 plus pi over 4, that's just going to be sine of pi over 2. And sine of pi over 2 is equal to 1. So even though this looks super daunting, the thing is, these values end up ultimately becoming something familiar and easy to evaluate with. So that's the method to the madness with all this. So let's keep going. Sine of 3 pi over 4. So if I evaluate that, that just comes out to sine of pi. Sine of pi is equal to 0. And then what about sine of 5 pi over 4? If I plug that in, sine of 5 pi over 4 plus pi over 4, that gives me sine of 3 pi over 2. Sine of 3 pi over 2 is going to be equal to negative 1. And I can continue this. So if I continue the pattern, and you can double check this on your own, I get 7 pi over 4, and that will give me 0 as my output. And then if I want to just keep going with this, just to check, 9 pi over 4, I get 1. So the thing that I'm looking for here is I'm looking for the pattern to repeat itself. So if you think about how the graph of sine works, so this is kind of taking us through a full loop. And then I just like to get this last one just as like an extra little check for myself. But notice, right, so these 5 steps, these are the key 5 steps that I needed. This started at the end point, and then this is the end. This was the end of that period that we were looking for, right? So we've got the start and the end of the period. Okay, cool. So now I want to graph all of these. So you're going to want to just create your axes and then plot points. So now, if I set this all up, I'm going to set this up with the scale that you see here. And here's my 1 and here's my negative 1. So if I now go through and I plot all of these points, and you might want to pause here just to get caught up. I'm like trying to keep this video short, so I'm showing you kind of the highlights. I do intend for you to be pausing and kind of working on this at your own pace. So maybe pause and plot your own points. When I plot my points, these are the ones that I have. And so if I connect them, okay, that definitely looks like sine just shifted over, right? And once I kind of establish this pattern, I can continue it on and I can make it go for as many periods as I want to. So what about if I have just a vertical translation? So what about 1 plus cosine of x? So the nice thing is with this, that like, first of all, with 1 plus cosine of x, does this move 1 unit up or down? This is going to move 1 unit up. And the good news is this is actually be significantly easier than when you have the horizontal translation. So that is the good news. So as far as like what my period and my amplitude are, so my period is 2 pi, my amplitude is 1. And then I know that if I just take 2 pi divided by 4, I'm just going to go pi over 2 steps. And there's no other funny business with like how to start your intervals. Since I don't have a horizontal translation here, when you do not have a horizontal translation, you get to just start at 0. So that's the good news. So if you have a horizontal translation, then you have to go through all that work of, you know, the starting with 0 and 2 pi. But if you don't have that, then you can just start at 0. And then I can just take pi over 2 steps after that, like I've always done. So pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2. And then I can go through and I can start calculating my y values. So if you only have a vertical translation, this is a little bit like more intuitive in some ways. But now you just have to be careful when you're calculating this. You have to take 1 plus each one of your results. So cosine of 0, for instance, is 1. So at 0, I'm going to have the point 0, 2. that's what this 1 is doing. It's moving everything up. So you're going to have like slightly different y values. Okay, so what about 1 plus cosine of pi over 2? So plugging in the next value. Well, that's just going to be 1 plus 0, so that's just going to equal 1. So we can just put a 1 there. And then 1 plus cosine of pi, that's going to come out to 1 minus 1, so that's going to equal 0. And then we can just keep going with it. I've got the rest of the work here if you want to see that and check that out. Highly recommend when you're doing this that you make sure that this work makes sense to you. Now, you'll notice that my y's are a little bit different from back when we were talking about graphs with just period and amplitude. So because this has shifted my y's up, I no longer go into negative numbers. That's okay, but we still have this rise and fall with our y values. We can still kind of see that, and we'll see how this plays out now in the graph. Okay, so I've got all my values, so I can go ahead now and set up my table. So I've got 0, 1, 2. I'm going to go in intervals of pi over 2, and then I can go ahead and plot my points again. And again, I recommend that you just take the time on your end to also plot your own points. So I've got all my points plotted here, and then I can go ahead and connect them. And then if I want to really blow this whole graph out, I could just continue the pattern like you see here. So I've continued my dots here, and I can connect them. And so now I've got this nice robust graph of 1 plus cosine of x. All right. So here's my last example, and I do want to challenge you to try a lot of this one on your own. So I'm going to give you some prompts to help you with that. Okay, so to start, we're going to identify amplitude, period. And why don't you go ahead and identify the phase shift and the vertical translation. Pause here for a second and hit play when you think you've found all that. Okay, so I've got amplitude. My period was pi. My amplitude is 1/2. My period is pi. My phase shift in this case comes out to pi over 2, and I will have a vertical translation. So these two things are just, this is going to move to the right, and it's also going to move down. So that just gives me an expectation of how the graph should look. Okay, the next thing I want you to do is I want you to find what is the starting and the ending point of our interval or of our period. So pause here, give that a try, hit play when you're ready. Okay, so to do that work, so I'm going to take the inside right and I wedge it between 0 and 2 pi. I add pi to all sides, and so I get the inequality that you see here. I divide all sides by 2. So I'm going to start at pi over 2, and then I'll end at 3 pi over 2. So this is my start and my end point. So I'll just note that to myself here. And then the other thing that I want to do is I want to note what are my steps. So I take my period and I divide it by 4. So I'm going to take pi over 4 steps. Okay, so I'm going to use my start point. So that's going to be pi over 2. And now I'm going to just set up these pi over 4 size steps to set up my table. So what I want you to do now is I want you to set up the whole table. So get the x's set up, pause, and then check, and then we'll keep going together. So pause here, set up your table, just the x part, hit play when you're ready. Okay, so if I go through this, so my next step is going to be 3 pi over 4. So I take pi over 2, and then I add pi over 4 to that, and I get 3 pi over 4. So you might have to be doing a little bit of work with the fractions to make this all work. Okay, so let's keep going. So the next step then will be pi, right? If I add pi over 4 to 3 pi over 4, I'll just get pi. And then if I keep going, the next step will be 5 pi over 4, and then 3 pi over 2. And then I always like to just do that last one as an extra bonus just to double check my work, 7 pi over 4. But the 5 steps that I needed, remember I started at pi over 2 and I ended at 3 pi over 2. So that was my start and my end of my period. So I've got kind of what I need. So now what I want you to do is I want you to pause the video here and I want you to fill in the y's and then hit play when you think you have figured that part out. Okay, so let's see. We're going to calculate the y's. So to do that, so I'll just show you my work. So if I plug in pi over 2, so what this will all simplify to then is 1 plus 1/2 times cosine of pi over pi. So that's 1 plus 1/2 cosine of 0. So this will come out to 1 plus 1/2, which equals 3/2. So I've got all my work there if you want to pause and review that. Okay, so next if I plug in 3 pi over 4, so what am I going to get for that? If I work out my math, I've got that written out here. I get that this will shake out to be 1 plus 1/2 cosine of pi. Cosine of pi over 2. Cosine of pi over 2 is of course equal to 0. So I'm just left with 1 plus 0. So this next entry will just equal to 1. So I'll keep going with this. So if I plug in pi, so I will have, this will come out to the calculation that you see here. So this will come out to 1 plus 1/2 cosine of pi. So ultimately, if I shake out the math, which you see here, this will equal 1/2. I'm going to continue on with 5 pi over 4. So if I plug in 5 pi over 4, I'm going to get, once again, just 1. So I've got all my math. I'm trying to keep this video shorter, so just pause the video if you need to review all of this. It's all there for you. And then I've got 3 pi over 2. So if I plug 3 pi over 2 in, so here's all my math. So this comes out to 3/2. And then if I were to calculate 7 pi over 4, I'll get 1. So I can see that the pattern is continuing, so I can feel confident about my math here. So just the thing I want to note with this, the reason I like to do this is, what if I ended up getting like 5 or something here, something that wasn't in the established pattern? That's like a tip off to me that I might have a mistake somewhere. So I always like to have like an easy way to catch an error. And I think this is just a nice way to do that by adding one extra step. Okay. So now I have all of my X and Y coordinates. So now what I would recommend that you do, go ahead and finish the sketch and then hit play when you think you've got it. Okay, so I'm going to go ahead and label my particular graph. So I'm going from 1, 1/2, 1, and 3/2, since those are really my 3 Y coordinates. So I'm going to mark those. And so then if I just mark everything, so here is what my graph should look like, and then I can continue the pattern. I can continue the pattern, and so you get a graph that looks like this. Okay, so it's a lot of work, but you know, once you kind of set up the table, it should make the calculations much easier. So this is the level of work that I would expect you to be doing when you're practicing the homework. Okay, and I think this video is long enough, so I'm going to leave it there, and I will catch you guys in another one.